Welcome everyone. Today we are solving problem 7.62 from Sadiku book. So the problem says for the circuit, calculate IT for I0 equals to 0 ampere. If we give a focus to this circuit, it has two voltage sources. One is UT minus 1 and one is UT. Right. As we know, we solved this problem earlier. So for those who don't know the problem, how to solve this problem, we have to calculate three ranges for this problem. The first range will be negative infinity to t to 0. Okay, for this range both of the voltage source will be turned off, both off. Okay, both will be off. For this range 0 to t to 1, for 0 to t to 1, this source will be open and this source will be off. So ut will be on and ut minus 1 will be what? Off, right? Okay, for t is greater than 1, both of them will be on. Okay, both of them will be on. ut minus 1 on, both of them will be on. We have to remember this. Now as we have already given I0 equals to 0 ampere, so they have already given us the value of this range. Okay, as we have discussed this earlier in a problem. So there are already the given for this value 0 ampere. Now we have to work with this range 0 to t to 1. Okay, for this voltage source will be opened, or else you can say it as on, and this will be off. Okay, so if this voltage source is on, then what will be the value of this? It will be obviously 1, right? So now if we replace the inductor as short circuit, if we replace this as short circuit, what will be the value? There will be no current flowing through this resistance, 3 ohm resistance, because it will be short circuited. Then there will be no current flow through this 3 ohm resistance, because the whole current will be passed through 6 ohm and then come to this and came its origin. Okay, so there will be no current flowing through 3 ohm resistance. Now if we calculate the through this voltage source, the value of current in this inductor will be I equals to what? I equals to what? 1 by 6 or V by R. What is the value of V? V equals to 1. And what is the value of R? 6. So it will be 1 by 6 ampere. Alright. So IT will be what? As we know, I0 equals to 0. So IT will be what? I0 e to the power minus tau by 1. So I0 t tau by 1. So 1 by 6 e to the power minus t by tau. What is the value of tau? Okay. What is the value of tau? Tau equals to, you know what? For inductance it will be L by R. What is the value of L? L will be 2. And what is the value of R? If we replace the inductors through these both terminals, then what will be 3 ohm and 6 ohm are in what? Parallel, right? 3 ohm and 6 ohm are in parallel. So their equivalent will be 3 into 6 divided by 3 plus 6, which is equals to 2. So 2 divided by 2 equals to 1. So it will be like this, or 1 by 6 e to the power minus t. Right? Now we have to work with the range t is greater than 1. For t is greater than 1, we have to short circuit this inductor again, and now both of the voltage source will be on. Okay, both of the voltage source will be on. Now the I infinity will be what? I infinity will be current through this, right? I infinity current through this. So there will be one current through this and one current will be through this, right? So for this voltage source there will be current through what? 1 by 3, right? For this voltage source, what will be the current through the inductor? 1 by 6, right? So it will be 1 by 6. So the value will be 1 by 6 plus 1 by 2 ampere. Now for this equation t is greater than 1, we already know the initial value will be I of 1, which we have calculated earlier, I of t as I of t. So replicate the value in place of t, it will be 1. So it will be 1 by 6 e to the power minus 1. Okay, so the value will be 1 by 6 e to the power minus 1, which will be 0.1054. Now we have to calculate IT. So what will be the IT? IT will be I infinity plus I0 minus I infinity e to the power minus t by tau, right? So we have already calculated tau, so we don't have to calculate this again, because for this and for if this voltage source will be opened, the tau will be remain same. If this voltage source will be opened, tau will be remain same. So we don't have to calculate tau again. So what will be the value of I0? Here I0 will be I1. Instead of I0 it will be I1 because the initial value will be I1. We have discussed this problem earlier, so I don't think I need to discuss this again. So I infinity will be what? We have already calculated 1 by 2 plus what will be the I1? I1 will be 0.1054 minus 0.5, because we can write this as 0.5 as well. So it will be e to the power minus t minus 1, because we are calculating this problem for t minus 1, and we know t minus 1 equals to what? 0. So t will be equals to what? 1, right? So for t equals to 1, we are calculating t in replace of t minus 1. Okay. Now the value will be 0.5 minus 0.1054 minus 0.5. It will be 0.3946 e to the power minus t minus 1. This what? Ampere. So IT will be this. So for the problem 7.62, the answer will be 0.5 minus 0.394 e to the power t minus 1 ampere. Now we have to solve problem number 7.63. The problem says obtain Vt and It for the circuit. Here we have a singularity function. Voltage is given as singularity function, which will be 10u minus t. As we know, for singularity function, we have discussed this earlier also. So u minus t will be what? 0 for t is greater than 0 and 1 for what? T is less than 0, right? Okay. Now for t is less than 0, what will be the value of u minus t? It will be 1. So the whole voltage source will be what? 10. And for t is greater than 0, if the value is 1, so the whole circuit will be in steady state mode. If the whole circuit is in steady state mode, we can replace the inductor as short circuit. So if the whole circuit is in steady state mode, we can replace the inductor as short circuit. So if we replace this as short circuit, then what will be the value of the whole current? 10 voltage will come through this 5 ohm, and there will be no current flow through this 20 ohm resistance. The whole current will flow through this 5 ohm, and through this short circuit path it will came again into the origin. Okay, so there will be no current flow through this 20 ohm. So the circuit will be look like something like this: 10 volt, and here we have 5 ohm, and here we have a short circuit, right? Okay, so it will be 5 ohm, it will be short circuit, and it will be 10 volt. So the current will be I0 equals to what? V by R, or 10 by 5 equals to 2 ampere, right? Now for t is greater than 0, what will be the value of u minus t? It will be 0. So the voltage source will be what? 0. So for t is greater than 0, the u minus t will be what? 0. So the voltage will be 0. So the current will be what? If there is no voltage, there will be no current flow through this inductor. So the I infinity will be also 0. We have I0, we have I infinity. Now we have to calculate tau. For inductor or RL circuit, we know tau equals to what? IL by RTH, right? What is the value of inductance? 0.5 divided by what is the value of RTH? RTH will be equivalent through these two terminals, right? So equivalent will be what? 5 and 20 are in what? Parallel. So 5 and 20 will be 5 into 20 divided by 5 plus 20. So it will be 4. So 0.5 divided by 4, it will be 1 by 8. Okay. So it will be 1 by 8. Now we have to calculate the IT. So you have to calculate IT. It will be, you just will be calculating this minus 80 to ut ampere, and the V2 will be the differentiation of what? L di by dt. So it will be minus 8 e to the power minus 80 ut. I hope you guys enjoyed the video. Thank you very much.